In the second half of section 5.3, we're going to solve polynomial equations algebraically. The advantage to doing this algebraically rather than graphing would be if I had imaginary solutions, which you'll see in one of these examples. If I had an imaginary solution to one of these equations, I wouldn't be able to see it if I graphed it in my graphing calculator. So to be able to see all real or imaginary solutions, the only way to really do that is to do this algebraically. In our first example, I want to find all solutions, real or imaginary, of 2x cubed minus 5x squared equals 3x. So to be able to find the solutions, what I want to do first for any of these is pull everything to one side to make my equation equal to 0. So here what I'm going to want to do is subtract 3x from both sides, leaving me with this equation. 2x cubed minus 5x squared minus 3x equals 0. What you want to ask yourself next, is there any greatest common factor I can pull out of all these three terms? Here I can see that every term shares an x, so I'm going to pull it out and I'm going to be left with this equation. X times 2x squared minus 5x minus 3 equals 0. From here, in my parentheses, I have a quadratic equation. So in chapter 4, we learned how to solve these either by factoring or by the quadratic formula. We're going to try factoring first because that'll be the easiest method, and if not, we would use the quadratic formula. So if I'm going to factor it, using the AC method, I want two numbers that multiply to give me -6 and add up to give me -5. Thinking this through, I could see that if I use -6 and 1, -6 times 1 will give me -6, and -6 plus 1 will give me -5, so that works out. I'm going to rewrite my equation with my factors, and then my last step for this is going to be to divide by my a value, especially since my a value is greater than 1, I need to do this. I'm going to divide the 6 by 2, that's going to go evenly and make that 3. Since the 1 doesn't divide evenly into 2, that 2 is going to carry over and go next to the x, so my equation will look like this. X times x minus 3 times 2x plus 1 equals 0. Since my equation is now in factored form, just by looking at this, I can easily, just by looking or in one step, figure out what all my zeros are. So to start, if I make that x value equal to 0, 0 times anything is 0, so that would work out. In my middle parenthesis, 3 minus 3 would be 0, so if I made x equal to 3, that would work out as well. In my last equation, if I make x equal to -1/2, that'll zero out my equation as well. And if you're wondering how to get that -1/2, what you could do is set that 2x plus 1 or whatever's in your parentheses equal to 0 and then solve for x. In my second example, I want to find all solutions, real or imaginary, to 3x to the 4th power plus 2x squared equals 6x cubed. Similar to that last problem, what you want to do first is get everything to one side. So I'm going to move that 6x cubed over, and I'm going to be left with 3x to the 4th power minus 6x cubed plus 12x squared equals 0. Also, like the last problem, I want to ask myself, is there a GCF I can pull? Here, I can see that all of my terms share an x squared, and not only that, but with that 3, 6, and 12, I can see that they all share a 3 also. So what I can do from here is pull out my 3x squared, and I'm left with x squared minus 2x plus 4 equals 0. From here, before I figure out what's in the parentheses, I can see that when I pull out my 3x squared, if I make 3x squared equal to 0, basically, if you pull an x out, 0 is going to be one of your factors. So x is equal to 0, that's going to work as one of my solutions. I'm just going to circle that for now, and then I'm going to figure out what my other solutions would be in my parentheses. From here, I'm left with x squared minus 2x plus 4 equals 0. So, similar to the last problem, first I'm going to try factoring because that'll be the easiest method if it would work out. So using the AC method, I want two numbers that multiply to give me 4 and add to give me -2. Thinking this through, I'm kind of hitting a dead end here because there's no factors that would multiply to give me 4 and add to give me -2. So if this doesn't work, what you have to use if you can't do factoring is you have to use the quadratic formula. So kind of keeping this equation here up at the top, still circling my x equals 0 to remember that for the end. Here's the quadratic formula. What I'm going to do is just plug this in, I'm going to find my solutions, and then I'd be done. So, plugging this into the quadratic formula, I would have negative of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4 all over 2 times 1. As my a value here is 1, my b value is negative 2, and my c value is 4 for this equation. Simplifying this down, negative of negative 2 would give me 2. Figuring out what everything in the parentheses is, making sure that I put that negative 2 in parentheses if I'm putting it all in the calculator, I would get negative 12, and then finally 2 times 1 in the denominator would just be 2. From here, all that's left to do is to simplify what's in my square root, and then I'm good to go. I see that I have a square root of a negative number, so I know that my solution is going to be imaginary. So what I'm going to do first is I'm going to pull out a negative 1. After that, I want to ask myself, just square root of 12 simplify. Thinking about all the perfect squares that could go into 12, I could see I could break this down into the square root of 4 times the square root of 3. From here, the square root of negative 1 would change to I, the square root of 4 changes to 2, and I'm left with the square root of 3. I know that I'm done because 3 won't simplify down anymore, so I'm good with leaving that in the square root. So just rewriting this, I'll have 2 plus or minus 2i square root of 3 over 2. I could cancel out all of these 2's, and I'm left with 1 plus or minus I square root of 3. So altogether, I have 3 zeros here, or 3 solutions. X equals 0, x equals 1 plus I square root of 3, and x equals 1 minus I square root of 3. For this problem specifically, I would only be able to find those last 2 solutions by doing this algebraically. If I graphed this equation, I wouldn't be able to see those imaginary solutions.